folks, and welcome to the channel, or welcome back. And in this video we're going to continue to work on the Ford Essex V6 in the TVR 3000M. Now in the previous episode we talked all about replacing the seals on the valve stems. We've done that, and there were a lot of good comments on that one, and some people asked me the question why I did not talk about the valve springs themselves. Why did I not check these, and why didn't I check the push rods? Well, I did, but since the video was all about replacing the valve stem seals, I actually didn't think I should put it in the video. So I'm going to do a recap of that, so you'll see on how we're checking the valve springs, their strength, their height, all that, and we're also going to check then the push rods for the straightness and the oil channel inside, because these are important checks. And then we're going to start looking at the valve cover, the leaks that we've had on this engine. The valve covers were leaking, so I'm replacing the valve covers, and there's a few things we need to talk about that right there, and a few changes and modifications we'll do. And if time permits, we'll actually look at the W plate inside the intake manifold, because the spark plugs that we have on this car all having a different color, and that is not normal. Maybe it's a carburetor problem, maybe it is a valve seal problem, that also is well possible. We'll see, but we go through all this. And I know many of you are waiting eagerly to see an old Rusty movie or video. Well, believe me, that is coming. But first I need to wrap up the TVR. So without any further ado, let's start looking on the valve springs. So I got the springs of the valves, one outlet, one inlet valve spring, and now we need to check the valve springs themselves. First of all, we need to check the height in freestanding. So for that you need a gauge, so let's measure that and see how tall that is. That is 46.17 millimeters. The other one is 45.46 millimeters. So they're not the same height. Although according to the manual, and now I need to put my glasses on, both should be the same, and they should have 47.955 mil. So I don't know if these are aftermarket springs or if they're modified something, but it certainly doesn't line up with the dimensions that I find in the Ford spec manual. Yeah, it's possible that they are changed afterwards and they put shorter valve springs in. Nevertheless, let's see what they do in terms of load. So how much pressure do they deliver? Because there has to be a valve load when the valve is closed to keep that closed, because it's a spring that needs to hold it. And when the valve is opened up, so being depressed by the rocker, then there will be more pressure on that valve spring here because it's really depressed down. And we want to measure that. Now, according to the manual, when the valve is closed, the spring should deliver a pressure of about 31.75 kilograms. And when the valve is open, so the spring is further depressed, then the load on that valve should be 68 kilograms plus or minus 3 kilograms. So now we should be able to measure this, because those are the important factors on those springs. Do they actually do that? Do they still have the strength, the spring load? And that's what we need to check. And therefore, we need to do two things. First of all, we need to find out what the height is of the spring when it's mounted on a valve and when the valve is fully closed. So for that, we're going to measure it on the engine block itself. If you're checking an intake spring, then look for an intake valve that is fully closed, like this one. So you have the play on the rocker, and then measure the height of the spring. But keep in mind the spring itself, and this seems to be 38.42, and remember that number. And now that we know the height of the spring for a closed valve when it's mounted on the cylinder head, we can now deduct from that 9.347 millimeters, because that is the valve lifting. So if the tumbler comes down, it's going to depress the closed valve 9.743 millimeters to have it fully open. And then of course then the spring is depressed, and at that time we need roughly about 68 kilograms on the spring. So now the trick is to create a little marker paper that we're going to put beside the spring, and then we're going to depress the spring to the closed position, and we read how much load we put on the spring, and then we're going to depress it further down to the valve open position, and then again we're going to check on the load that the spring is providing. So these are the two tests we're going to do, and that is not very difficult. So I'm going to depress it first to the first marker, which is marked with 31.75 kilograms. Now that first marker there is just the one we measured when the valve was fully closed. You remember we measured that distance, so I did use my gauge and I marked it on a piece of paper with that little line there to show that this is actually at the position of the valve closed. So if I now put pressure on the spring and I depress the spring up to that first mark there, then I can read out on the scale which is underneath here, which is just a weight scale that I use in the house. I should be able to see how many kilograms that is. It's going to be a little bit tough to show you that, but you can use any scale you want, and I just put a support block underneath. Now I know it's not 100% accurate because I have a wooden block and the weight of the spring itself, so I will need to deduct that, but you can measure that afterwards and then deduct it. I just want to show you the principle on how I do that. So the second line that you see on the paper, that is actually when the valve is fully open. And when the valve is fully open, we should see a pressure of 68 kilograms on the scale here. And the difference between the two markers is actually the valve lift that we have on that specific valve. So now it's time to start pressing and see what we have here on the dial, on the gauge. I don't know if you will be able to see it, so you will have to trust me, guys, I guess, because this is a bit high up. But this is a modern scale and they turn off automatically, so I have to push it once to get it engaged, and now I can lower down my press and depress the spring until we are at the first marker, and then check the scale here, what the scale will indicate. And we are about at that point, a little bit more, and I see that I have 31 kilograms, so that's good. So now let's go to the second marker, which is the valve fully open. And now I see 67 kilograms and a half. So that is good. All right, so that spring seems to have the right load on it. The only thing that it doesn't have is the proper height, but I don't think it matters because we have the proper spring loads. So now that we have checked the springs and they still seem to provide the proper load, although the height isn't accurate according to the manual, we need to check the push rods, and this is a push rod, and we need to check it for two purposes. We need to check the straightness, but there is also an oil channel straight through it, and we want to make sure that this oil channel is open. So checking the straightness is an easy test, and I'll show you that in a second, and then of course verifying that the actual oil channel is open. It's just spraying some liquid through it and then blow it out with compressed air and see if everything comes through, and then that should be good. For the straightness test of the push rod, you don't need to make it very complicated. Take a piece of very flat glass, put it on the slide angle, and then take your push rod, make sure it's clean, leave it on there and let it roll down slowly. And it should not be wobbly, it should be rolling very smoothly. If it's crooked or bent, you will see it. So let's do that. And that looks quite all right. The alternative is that you just put it on the flat piece of glass again, put it on there and use your hand like this, and you will feel it if it's crooked or not. You don't need any fancy tools to do this. This is a very easy and simple test. Now if you look very closely, you will see that the push rod has a little opening in the middle here, and it's the same opening on the other side. So I'm going to blow that through with some cleaning liquid and then see if it comes out on the other side. And as you can see, that is pretty clean. And then at last I will blow it through with some compressed air just to make sure that it's absolutely free. And this is an example of a bent pushrod. Now it's already obvious, as you can see, this came out of cylinder number 4. But if you do the same test, you will see how badly that runs. So even with your hand, you know, you can barely move it. So this is pretty badly bent, so we have to replace this one. In this video, we're not going to replace the push rods because that was part of the previous video, so meanwhile they have been replaced. Also, if you remember it right, we were looking on the spark plugs in the previous video, and we noticed that the first two spark plugs were kind of like white, so they were running a little bit hot. The other ones were arranged between kind of coffee with milk, but some of them had a lot of deposit on it. And if you go back to the video where we actually started to check the compression, you will see that. And that's quite obvious because a lot of these valve seals feel like rocks now. These are the old ones, and they were really worn out. Anyhow, but now it's time for something else. We're going to replace the valve covers. And these are the original valve covers that were on this engine. And they are made out of thin material. And I'm going to replace them with something else. And you can already see the big pile of silicone and broken gaskets that were on these valve covers. And that caused quite some oil leaks. So let me show you now what we're going to do with these valve covers. I'm replacing the original valve covers, which are thin metal, and they are a bit lower, as you can see, than the new ones, and I'm replacing them with a cast-based alloy. It's a lot thicker than the original ones. This is very thin material. This is at least 0.5 centimeter or 5 millimeters thick, and probably even more than that. And these you can get at Burton's Power. Not that I'm making a commercial for them, but they look real neat and real nice. Now, of course, when you buy them, they don't look like this, because when you buy them, they just look like this on the inside. So just bare metal. They're a bit rough, so they are not very smooth, but they have a nice surface top where you have the letters Essex V6 and you have some lines, so nice detailing on that one. So if you're going to spray them, as I did, and I painted them with high temperature engine paint up to 800 degrees centigrade, it's good to go for some matte paint or semi-gloss. I wouldn't go for gloss paint because of all the little unevenness that on it because of the casting, but I don't care about this too much. So now the question now is, why did I go for these? And I have about 4 reasons why I went for this type of valve covers. First of all, they are thicker, so they deform far less. If you look on the original ones, and I don't know if you can see it, but I will take a close-up very soon, you will see that the edges here are actually deformed. And that is because people tie them down too hard sometimes. You have to respect the torque. But also, if you're changing the valve covers, you need to change the Kirk seal every time you replace it. And if you don't, then of course that Kirk seal has already been depressed to some extent, and then you put the cover back on, and then people tie them down even more and more, and before you know it, you really have an uneven surface here on this valve cover, and then of course the leaks are happening. So if I look along this line, I can actually see the curvature on this valve cover here, and then obviously you get leaks. And what do people do then? Oh well, they dissolve to silicone, right? So this was one of the main big issues on this car. There was so much silicone on it that it was more silicone than engine at the end. So that's why I got rid of this. These new covers, they are far more smooth. You can actually see that. I mean, they are really straight. They are nicely finished on the back side, or the part that sits on the engine block. It doesn't have the actual edge that you have here. Here you have an edge where the seal sits in. You don't have it with this one. So I'm using a new rubber seal that goes with this. And the rubber seal you will have to fit without any silicone, without any oil. You need to fit it dry. And of course we'll have to clean up the cylinder head where the cover is sitting on. So that was the first reason. So this is not going to distort. That's the first reason. There's a second reason for that. As this is thicker material, I will have far less noise, valve noise. I know this may not be a big deal because we have a loud exhaust on this car and you might not even hear the valves, but you can imagine. You can hear the difference, right? This sounds very, you can hear the difference, right? This is like a tin can. and it amplifies the noise of the valves. This one is far better in isolating it. But okay, that is not really a big advantage. But the third reason is also that I'm going to fit later rollers instead of the normal rockers that are on this car. And if you're going to install rockers, then the original valve cover isn't high enough, the shape isn't good enough, and you can actually see it if you compare the two to each other. This one is quite a bit higher and it is more angular than the old one. So if you're going to fit the rollers, you have to get new valve covers. Now, I have not fitted the rollers yet, but I will do so by the end of next year, or the end of this year I should say, because you have to take the cylinder head off and you have to replace the studs that are in the cylinder block, and the problem is that the studs that are in it are pressed in it, so you need to get them out first, and then you put some thread in so you can put the new studs in so you can hold the rollers. But I'm not going to do this now, but at least I'm ready for it, so I'm already kind of aligned for it. And of course the last part is I like the looks of this. I like this blue, I like the details on it, and of course they don't come like this, and let me show you what I've done with the one that I have laying around, which I haven't done yet. I only painted it, but I'm going to show you on how I bring up the detail on the top here. All right, enough of those two. So now let's look on the other one, the other cover. Now this is the other cover, old one, and as you can see, we have an opening here, and in essence you have the PVC valve, PCV valve sitting in it. Sorry, PVC is something else. So it's the PCV valve, and this is actually the valve right here, and that sits in there with a grommet or a seal, and that goes to your carburetor. Now the problem is on the second alloy valve cover that we have, that is not foreseen. There's only a flat surface on it, and let me show you what that is. On the old cover we have the fitting for the PCV valve, and here is that valve, and that sits actually in a grommet that goes inside. So if you look on the new valve cover, you don't have that opening in the same place. You have it on the other side, and in fact the opening isn't there. I just drilled that out, but you have a surface where you can actually do it. It would be something I think for Burtons to work on, and making sure that you have a match on the other side. It almost looks like I've got two covers for the same side with a filler on it. Anyhow, so now we'll have to fix this. So I drilled with a 19 millimeters or 3/4 bit a hole right here, and that goes quite smoothly because this is an alloy and it's not that hard, and that's just big enough to fit that seal here, or that grommet. Now I'm going to glue that in there with Tech 7 so it can't move. And now I can fit my PCV valve, that goes right in there. Now of course the hose has to go back to the carburetor, and you can see the difference between the old cover and the new one. So I have to make a pipe that goes to the carburetor. So if you're going to paint the covers, you don't need to mask all this detail off. Now of course if you like to do that, you can put some tape on it, cut it all out, and maybe have some small tape, but the letters will be a bit difficult. To me there was no need for that. I just painted the complete cover, and before the paint was really dry, so still a little bit elastic, I took a piece of hard plastic and I scraped off some of that paint. And now all I need to do now is use a sanding block, and this is a fine sanding block, and rub over that, and you'll see I'm going to get the same finish on this one as I have already done on the other one. So let me just do that. Now this is not going to go right away, it takes a bit of time, but not that much. Probably in about 15 minutes you get it out, and you can already see it coming. So I'm going to use a bit of more corrosive sanding block. And this works very easily, guys. So as you see, it starts to come, and it's just a matter of rubbing. So I'm going to continue with this, and then I'll let you see the final result. And here it is, all rubbed off. If you like to have more shine, then go to a grit 1000, maybe 2000, 3000, and you can even polish it if you want. Now for me, I have enough gloss on this, I don't need more gloss than that. And now we're kind of ready to mount them. But before we do so, I still need to do something on the cylinder head because there's still too much silicone on it. And as you might have seen in previous videos, the cylinder head where the valve cover fits is really glued together with silicone, so now we need to take it off. I already took quite a bit off, and therefore I'm using some sealant remover. This is easy stuff. You spray a little bit on it and then it comes off very easily. So let's start and remove some of that crap on the cylinder head. So to make it all a bit easier, I'm going to remove the carburetor because we need to do some work on this carburetor anyway. But that's going to be for the next video. And by the way, this hose here, that's the hose that goes to the PCV valve. I already unlocked the carburetor on the bottom, and you might as well remember that we had some hot spark plugs. They were really white on the first two cylinders, and the other ones were a bit polluted, let's say. Some of it was because of the seals, of course, but maybe the carburetor needs some good adjustment, and maybe the W plate might not be in this car. I don't know, I haven't checked it, so that's why I already removed the screws on it and the linkage on it and the fuel pipes. So now we can take the carburetor off and have a closer look. And I can see that I do have a W plate, because you never know what people do with cars, and the name W plate comes from this W form here. This has been put in to have a better distribution of the mixture to all the cylinders. If you don't have this in, then you may not have an optimum distribution of the mixture and the engine isn't running all that smooth. So I'm going to take this off. I don't want to mess up too much the heat wrapping, so I'm going to cover that up a little bit. But you can see all the silicone that is on here still, and it's all over the place, and already peeled off a whole bunch of it. So now I'm going to spray that in, and then we're going to scrape it off gently and then clean it all up, and then we can mount the new valve covers after we have retapped these holes, because even those holes where the screws go in, they sometimes are filled up with silicone. I had it on the other side, which I did already, so that's the bad thing about silicone. It gets in everywhere, and if you get it in your oil channels, then you really have a problem. I'm going to let this soak for a little bit, so then it becomes loose much easier. So scraping that off goes very easily. You don't want to get the silicone into the cylinder head, and as you can see, this is very easy to do. Fortunately, I did a part already in the front here, and I forgot to turn on my camera, so it happens all the time with me. Must be the age, I guess. You know, I never understood what people have with silicone. I mean, I see sometimes complete surfaces covered with silicone. I mean, really, that doesn't make a lot of sense, does it? See how much came off already, huh? This is all crap silicone leftovers on that edge on the cylinder head. So now I'm going to clean up the cylinder head with some acetone, and then we're going to mount the new covers. I don't want to have residues of the towel or the paper actually inside the engine block, so sometimes it's better to use a piece of cloth if you have one. There's sometimes silicone even at the inside. And to finish it all up, I'm going to use a soft sanding block just to go around the edges, just to make sure that there's nothing left on it. And this is the rubber seal that we're going to put up. It's a fairly thick seal. It's about 3 to 4 mil. And I think it's a lot better than the Kirk seals. So you can see the little tabs on it. Now obviously these tabs we won't need anymore, because that's built or made for the old covers where you had these little cutouts. On the covers we have right now, we don't have that because it's a flat surface. But before we're putting that up together with the covers, I will still have to tap out these holes where the bolts go in, because I have brand new bolts, and I'm sure the tap holes are actually full of debris as well and silicone. So let us tap that out first. So I'm going to use a tap, and of course with the right thread, that's important, and gently turn it in there, trying to clean up whatever is inside. Don't know how much is in here, but I had in the other side a lot of debris inside. Let's see. This doesn't feel too bad on this side, but once we take it out, we'll see how much junk and crap is inside. You can already see what's coming out, right? Look at that. And I can see already chunks of silicone on it. See that? All this crap, and most of it is actually silicone. Yep, it is silicone. Everything is nicely cleaned up, so now we can actually put the cover up. But first of all, the seal goes on, and remember, the rubber seal goes on dry, and it might be a little bit tricky to get them in the right place with the cover, but once you get the holes aligned, you can use a little screwdriver to position it. I try to align it with the holes, and I use a little screwdriver to have that alignment. I'll leave that in there for now. These are brand new bolts, and we call them in-bus, so let's see if that fits. I've got the valve covers on the block, and the bolts that I had were a little bit too short. I mean, they grab, but not enough. I mean, maybe they grab for ½ centimeter, and I don't like that. They should grab far more. So I'm going to get some longer ones, although they came with it. So, you know, sometimes parts that you order up, I don't know who throws those together sometimes, because sometimes it just doesn't make sense. Anyway, I'm going to order up those new parts. Anyway, so if you put the covers up, it's okay to tighten them down, but don't over tighten it, because you don't want to pinch that rubber seal. You just want to have it squeezed a bit, but not pinch it. I've kind of torqued them to the same level, and I think the seal seals off nicely. But now I'm going to warm up the engine once I have the cooling system in it, and once I have done the ignition, and once I got sorted out the carburetor. And then I need to readjust the valves anyway, because we did a cold adjustment, and we should do it with a warm engine. So the covers have to come off anyhow, and at that moment in time, hopefully I will have the right bolts for that. Now, the issue is now that the W plate, I have it right here, has to go onto the engine block. And as you can see, the tube doesn't fit anymore, so we need to get this tube over here to the PCV valve. And therefore, I'm going to turn a black piece of nylon so that can fit in there nicely, so it's all sealed up, drill a hole on the side, and then fit a tube. And this is an aluminum tube that I'm going to fit onto that. And that's going to feed into this hose right here. I might have to cut this hose and then put a connection piece, 2 bands, and then turn that over so it fits better. But before I do that, I'm going to mount the carburetor to see if that is still fitting. So folks, we've come to the end of this video, and in the next video we're going to turn these parts for the PCV valve and its connections with the other tube. And then we also will start looking at the carburetor, and hopefully by then I have the overhaul kit for the carburetor, and then we can do all this together then in one video. And the video after that will all be about the cooling system. I got all the parts by the way now, so that's good. And then we can actually wrap it all up, and hopefully we can crank up the engine then and see how it runs. Please, by all means, comment as much as you want, because I do enjoy your comments. Bye-bye.